Okay, let's have a quick look at this. So we got this weight coming, dropping down, which is going to be 0.4 G. So that's going to be acting perpendicular to the plane, coming down parallel to the plane. That's 60. So that will be 0.4 G sine 60. Coming down will be 0.4 G cos 60. This Q is a weight of 0.3 G. So tension's holding that, which is also the same as this, as the same string. Now that will be reacting from here, so that's called Rn, reaction force, and this will be perpendicular to that with the tension going that way, and that's be 60, so that will be 30. So there'll be a force of the tension times cos 30 going that way, and there'll be a force going upwards which is parallel to that, which will be T sine 30. So there's a lot of action going on. So let's just separate all this. So we need to look at all the components which are parallel to the plane and perpendicular. So let's look at the parallel to the plane. So what we got here, parallel to the plane, so we got friction, and can also put friction is going that way, which is also playing a part to holding it up. So we got tension plus friction is going to equal, is going to balance with this weight on the slope, 0.4 G sine 60. Take the tension. Oh, before we do, we can work out the tension, because tension is the same as here, so we can say that tension is equal to this weight hanging down, which is 0.3 G. So therefore friction will equal to 0.4 G sine 60 minus 0.3 G, and that's going to give me a friction of, if you put that for your calculator, you'll get 0.844 newtons. Okay, and what's happening perpendicular? We've got Rn is going up, so these are perpendicular now, and that will be Rn going up plus this tension going up on the slope, so that's going to be T sine 30, and that's balancing with what's going down is this, which is going to be 0.4 G cos 60. Now that will give me Rn equal to, take that to the side, 0.4 G cos 60 minus 0.3 G sine 30. If you put that through your calculator, you're going to get 0.49 newtons. Okay, so we're done with the parallel force there, perpendicular force there. Coefficient friction of P on the plane. So first of all, friction is equal to mu times Rn. We worked out friction here, which is going to be 0.844 equals to mu, and Rn we worked out to be 0.49. So if I divide that through, mu will equal 0.844 shared by 0.49. Mu will equal 1.73. It's two decimal places. Okay, so coefficient friction, done that one, so that's B. This was A. Now it says here B is held at stationary and P is held at stationary, and the particle of mass 0.2 is attached to Q. So I'll make it 0.5. With the with string straw, P is released from rest. So if that's released from rest, it will lift up. That's going down, and that will be start lifting up. So if that lifts up, okay, then it will have no contact. Just gonna quickly 0.3 times 9.8, just to make that point. Yeah, so that will lift that up, that will increase that tension. Okay, reset from let's calculate the tension of the string, acceleration of the particles. So what will happen is now there's just going to be vertical motion happening here, so you end up only the vertical, there's no more attachment to that slope. So this will come down at 0.5 g and the tension going against it, and this particle P, that's the Q, and the P particle, which is 0.4 g, will be pulled up, the weight going against it. So the motion will start this way. So what we get is we get 0.5 g minus the tension equals to, that weight is going to be 0.5 a, and here you're going to get the tension is going to be pulling it, and going against it is weight 0.4 g, and that's going to be 0.4 times the acceleration. So if we add those together, simultaneous equations, the tensions will cancel, we'll get 0.1 g equal to, add those together, 0.9 a. Therefore a will equal, if I divide that through, it'll be 0.1 g shared by 0.9. If I do that on my calculator, 0.1 times 9.8 over 0.1, and I'll get acceleration to be 1.09 meters per second. And if I now sub that back in to get the tension, my tension will equal 0, so I'm going to take that to the side, becomes 0.4 g plus 0.4 a, and a is 1.09. So my tension now is going to be, times that by 0.4, add 0.4 times 9.8, and that will give me a tension of 4.36 newtons. Okay, so we've done that bit. So what happens in this case, as that weight is heavy, that will go down and that will lift up. Okay, since that weight is heavier. Okay, it's a bit of a tricky one. Loads of forces happening here. You're just gonna have to slowly separate them and then just break it down. Okay.